Hi everyone, this is Andrew, and today I'm going to show you the implementation details for my state machine solution that I've been using in Heavybeat. So as you probably know, if you've been following this channel for a bit, I've uploaded a video about, let's say 4 weeks ago or 2 weeks ago, I'm not sure, but it's a video about the state machine implementation in my game. And a few of you have asked about more specific implementation details, such as code and an actual example of it working in something else other than my project, and stuff that I can actually show and share with you guys. So I figured I would be recording this kind of video, which I'll be calling from now on a workshop, where I go in depth with a few of the implementation details from my game. So right now I'm going to show you how you can recreate my state machine implementation, which is based on U objects in Unreal Engine. And we're going to do this together from scratch. So these kinds of videos will be, which I call workshops, will be pretty much unedited, unless something really bad happens during my recording. But most of it will be unedited, so you can follow along and you can code it yourself. And yeah, hopefully we're gonna have some fun. So we're gonna start off with the third-person character project example. So this is just the project. So if you go to if you go to Epic Games here and you go to the Unreal Engine and you launch it, you should be able to see that you can create a new kind of game and you can choose third person. This is basically what I've done here. I just opened it up right before I started recording. So go ahead and do this. And the way I'm going to show you how the state machine is implemented is by trying to split the functionality of the character into multiple states. So what we're going to do, we're going to play with some character inputs, and we're going to make the character do certain things based on the state that it is in. And one reason why we do this using state machines is to encapsulate as much functionality as we can and compartmentalize everything in separate objects. So we don't have a huge, if you've worked on a pretty big game yourself, you would know that your characters usually end up looking like thousands of lines of code, if and else checks everywhere, and switches and everything, and enums, just to figure out what the character can and can't do. So an answer to this would be state machines, and there are multiple ways you can implement them. My solution uses U objects, but if you want to use, for example, there are some solutions using gameplay tags. Other solutions use actor components. You can choose anything you'd like, but my solution uses U objects, and I'm going to show you how to actually implement something like this. First of all, let's prepare the input part of our character. And the way we're going to do this, we're going to use the space key to do some different things with our character. So if you go to the project settings and you go to input, you should see that you already have a jump key defined for the spacebar. And this has a bunch of other keys here for other platforms and for controllers and so on and so forth. But as long as it has spacebar here, or it can be anything else really, but as long as you started this project from scratch using Epic's template for a third-person character, then you should have this action mapping here and everything should be fine. But one thing we're going to do real quickly is go to code. So if we go to our character CPP over here, we can see that there is already a function here that's going to set up player input components. That's going to set up the input for the player. And it already binds the action jump. It binds the pressed and the released. So we're going to comment these lines because we don't really want our character to handle anything regarding input. The way we're going to do this is we're going to make the player controller handle input through it. And then we will delegate that input to our states. So one way we're going to do this is we need to create a player controller from scratch now. So if you go back to Unreal Engine, we can create a new C++ class, and we're going to choose player controller from here. We're going to put it in the same module. We're going to hit, We can leave this blank, actually. We don't want it in a separate folder. Actually, let me check if we have it. Okay, yeah, that's fine. So where you put the H files or CPP files, that doesn't matter at all. Let's call it my player controller, why not? Or actually custom player controller. We're creating the class. There we go. It automatically opens Visual Studio for me. I'm using Writer right now, but yeah, this is annoying. But let me just exit real quick from here. Should be available in Writer as well. Yep, there we go. So we now have a player controller H and player controller CPP. And what we're going to do is we're going to go back to Unreal. We're going to create a blueprint based on this player controller. We have to search for it. So custom player controller. There we go. Let's call it BP custom player controller. And we have to set it as our controller. So if we go to maps and modes, you should have the, oh, I think we need to create our new game mode, right? So, okay, let's create a new game mode as well. I think we have to do that. Yep, okay. Let's do a quick game mode as well. PP custom game mode. All right. And now we can set the game mode to the custom game mode, the pawn class to the third person character, and the player controller to the BP custom player controller. And now if we play, everything should work fine. And we're using our own game mode with our own controller. And just to test this, I'm gonna do this real quick with the player controller. I'm going to print string over here when we enter play just to check if we have the correct one. And yes, we can see the hello there, so it is the correct one. Okay. That's it for now for blueprints. Let's go back to C++. And if we select our player controller over here, okay, so we're going to override some functions from our parent class over here, which is a player controller. And we're going to override setup input component. And we can go ahead and generate an implementation here. So now we are in our CPP file for the player controller. And we're going to define what this setup input component does. And we're going to call the super for the input component function. And then we're going to bind our actions here. This is basically exactly what's happening in the character over here. It's just that we're doing it in the controller. So for example, if you want to bind some actions that will only affect UI, then you can do it through the controller and then send some signal to some UI that some button has been pressed. So you no longer have to talk to the character directly, you just have to talk to the controller, which is pretty neat. And now you can go to the input component, which is a natural variable which is a variable in the A player controller. And we're going to bind an action jump. And we're gonna do it through, do this to on pressed, this to a custom player controller. And now we need a function for it. So we're going to create a function in the public and then do void press jump. Let's generate the implementation for this. And now we have our function. Press jump. There we go. So basically, now if we press jump, we should be able to, if we press jump, this function will be called. And we can actually test this if you want. If we use gengine and add a on-screen debug message, let's show it for about 3 seconds. Let's go for a red color, and I'm gonna show it like I pressed the jump key. Right, now we need to build this. So if we need to build this, we need to close our Unreal Engine because we've modified, we don't really want to hot reload anything. Let's build a solution. Boom, there we go, it's all built. Now let's open it again. Let's see, there we go. Okay, and now if we press play and we press space, you can see I pressed the jump key and the character no longer jumps, because if you remember, we unbound the action mapping from the character CPP, which isn't something you're going to do if you start from scratch with a simple pawn. But since this is their example, you know, they already bound the jump key, so we're just now using it to our own purpose. So now that we've bound our jump key successfully, now we need to create a delegate that will broadcast to anyone listening that, hey, I've pressed the jump key. So the way we're going to do this, we're going to define the delegate in an interface that is going to be implemented by the player controller. The reason why we do this is because if we have any other element in our game that wishes to know if the player has pressed jump, we don't want that element in the game, object or whatever, to know the implementation, to know about the player controller itself, but only an interface, which will only contain whatever we need to expose to the public. So if, for example, some UI piece, let's say a widget, will need to know if the player pressed jump, the widget will not have to know, for example, if the player controller does anything else. It will just know about the jump, and that's it. Right, and the way we're going to do this is we have to create an interface. And the way we're going to do that is through Unreal Engine. So if you go to new C++ class, you'll be able to see that at some point we can create an Unreal interface. And we're going to go hit next. We're just going to keep it in the same folder, and we're going to call it custom player controller interface. And we're going to create class. Boom, it's going to open Visual Studio as well, but we're going to exit promptly out of it. We don't really need it. There we go, because we're using Rider. And now let's go to our interface, which is over here. This is what it looks like. And we need to build a delegate here. So we're going to go with declare multicast delegate. I'm gonna call it f jump signature, and that's it. Right, so now that we've declared the delegate over here, we can also declare a function that will retrieve this delegate for us. We can do virtual f jump signature, and we just need a pointer to this type, get jump delegate equal 0. And now that we've created the interface, we can basically inherit from it like this. And now we can actually access that delegate, and we can create types of that delegate. So if we define a delegate variable like this, f jump signature, we're gonna call it f jump. We're gonna call it jump delegate. Like this, and in protected we can actually override virtual void, not void, but f jump signature get jump delegate override. And now we're going to generate this implementation, and here we can return jump delegate. We can actually return a reference to this, which is going to work flawlessly. So now whenever we call this function, we're going to get our jump delegate, which we'll need further down the line. But now let's just keep going with this. If in the jump function, if the jump delegate is bound, then we're going to execute. We're going to broadcast this to everyone that is listening, just like this. So now if anyone retrieves this variable through this function, actually, if this is, we're going to do this in private, like so. So now if anyone retrieves this variable, this delegate through this function, it will know if the player pressed jump or not, which is pretty neat. And we can do this by only communicating with the interface itself and not the player controller itself. Now, on to the actual state machine implementation. This has been the setup for the project, and now let's do the state machine implementation. So the way we're going to do this is we're going to create this state machine as the state machine implementation as a plugin. So you can actually use it for multiple projects and not just this one, for example, but you can do it in any way you'd like. So if you want to create your own classes, if you want to put it in the same module and so on and so forth, you're free to do so. So all we have to do is go to plugins. So here we're going to just enter a name for our plugin, which is going to be really simple, just state machine plugin. Custom state machine, that'd be better, right? And we're just going to hit, we can actually need to choose over here. We're gonna go for blank, and that's about it. Let's create the plugin. Right, so now that it's finished creating it, we can actually see it here, custom state machine in the plugins list. And if we go to our code, you can see the separate module over here in plugins called custom. You can see the separate folder in here through plugins, custom state machine, and we have a separate module, custom state machine as well, and a private and a public folder. So now that we have created our plugin, we can actually fill it with some stuff. And the first thing we're going to define is a state manager component. So we can go ahead and create a UActor component through Unreal, using the same method as before, new U class and new actor component. We're going to select custom state machine this time, and we're going to make sure we click on public over here. And we're going to call it state manager component. Boom. And while we'll add it, we're going to create a state base as well, which is basically the base class that every kind of state that we're going to define further down the line will inherit from. So we're going to go to UObject over here. We're going to inherit from it, and we're going to add it to custom state machine as well. We're going to call it state base. And we're just going to create a class. There we go. Right, now we should see everything here. Have our state base and our state manager component. Let's start with the state manager component. Or actually, let's start with the base. The base seems a lot simpler to start off with. So let's just go with the base. Right, so we need to define a few variables here in the base. We're going to define something, uProperty, blueprint, read only, edit defaults only. We're going to define if this state can tick. Next, we need to define another Boolean that we're going to use to see if we can repeat the actual state we are in. So for example, if you switch the state to the same state you are in right now, then is the state manager component, is the state functionality allowed to run again, or will it just throw an error? So we're going to do this like B can repeat, where it's going to be false on default. And then we need a state display name. This is basically mostly only for debugging purposes. Next, we're going to create some public functions over here. which will all be overridable. So we need a function to execute when we enter the state. And we need a state owner parameter through it. You're going to see in a few minutes why. We're going to have a tick state, which is basically the function ticking every time the main component ticks. A virtual on exit state. Right. That's basically it for the state base. Now let's move on to the state manager component. And in the state manager component over here, now let's move to the state manager component. And in the state manager component, we're going to have a few things, but we're going to start off with, let's see, we're going to start off by including our stuff. So state base, and we're going to include, that's about it, I think. Okay. Now we're going to go down to public, and we're going to have a few properties over here. First of all, we're going to have a string that's going to define the initial state that the actor will be in. We're going to have to make a tmap with fstring and t subclass of uStateBase. This is basically the available states of the state manager component. So if you want to use the state, it's going to have to be in this list, otherwise you won't be able to use it. We're going to have a boolean that's going to say if we're going to debug or not. We're going to have a state history, a t-array of uStateBase pointers. This will basically be used to see, okay, the history of the state. So for example, the state previous to this, which one was it? And you'll be able to read it from here. We're going to have a state history length, a current state. We're also going to have a current state and a tmap, a state map, and for the last variable, we're going to have a tmap containing an fstring and a uStateBase pointer called statemap. Now, the interesting thing here is that we have available states and statemap, and the only difference between these two is that available states uses subclass of uStateBase, and the statemap uses uStateBase pointer. This is basically because the way this functions on begin play, the state manager component will create every single state that it can find in available states, and then based on your implementation of the functionality, it will basically switch states on demand. So it will, for example, if you have like 5 available states, so the character can be in the air, it can run, it can idle, it can attack, and it can defend, then everything gets every one of these states, which are basically, if you go back to state base, they are U objects. Each of them will be created on start. And then whenever you need the different functionality of different states, then you will be able to just say, okay, I want this state active now, and the rest will be deactivated. So you will only have one state. You will only have one state that handles functionality at all times. Right, and we need three functions as well. Actually, only 2. So we have these 2 functions, switch state by key, which will basically be the on. This will basically be the function you call whenever you want to switch the state you are in, and it functions by providing a string. And we have the init state manager, which we basically call on begin play, which will handle all the initializations. And you'll see in a second how that functions as well. But we have 2 more variables we need to define here. A variable that says if we can take the state, and a variable that initializes states. And we're going to generate implementations for everything. So this one. Why did it do it in line? Okay. Okay, this is bad. Let's just do this real quick. There we go. And we go to the CPP file over here. And we have it like this. Ooh, this is bad. I can actually... What the hell? Okay, there we go. That fixed it. Now I forgot something. Okay, I forgot something. We need another function over here that's going to switch the state by a useState base. So like this. So we have one functioning through a state key and we have one functioning through a state itself. And you'll see in a bit why we need this. We're going to generate implementation for it. Right, and we're gonna call this one new state and this one new state. Okay. So now that we have declared all our variables and all our functions, it's time to actually implement them. We're going to start off with the initialize states. This basically is a for loop going through all the available states we have, and every single time it finds one, creates a new object, and then adds it to the state map. Really, really simple. Then let's move on to the switch state by key. So we're going to have to find the state in our state map. New state. If we found a valid state, do a normal state switch. So this is the only abnormal thing that we need to do at the start. Else, we need to check if the state is or is not repeatable. This, I previously mentioned this. This basically means that if is the state going to be executed twice if I switch to the same state. So if right now I am in idle and I attempt to switch again to idle, will the onEnter function and onExit function trigger, and so on and so forth. So basically what I'm doing here, I'm checking, okay, is the current state the same class as the new state? And if so, is the current state B can repeat variable false? And if this happens, this basically means that we cannot switch the state because the current state is non-repeatable. So we're going to add a simple message over here. And if you're wondering why I'm copy pasting and where I'm getting all these copy pastes from, I have my own project opened on the second monitor just for consistency's sake. So basically this all checks if the debug is on and then provides a screen message that's going to say, okay, state switch failed. We get the state display name from the current state and we just say that, okay, this state is not repeatable, so we can't switch to it. Really, really simple stuff. All right, next we have an else, which basically means the state is repeatable. So we are going to switch to that state. And we're first going to stop any ticking going on. Then we're going to call onExit function for our current state. Then we're going to add the current state to the state history. So the state history map. And so this part over here handles the state history. Basically what we're doing, we're pushing the current state pointer to an array that's going to hold a pointer to every single state that has previously been, that the actor has previously been in. after which we're going to set our new current state, which is going to be new state, the one provided through the parameter. And then we switch the current state to the new state, the one we created on top. Right? And for our last thing, we need to call the state initialization for the new current state. So if we have a current state, so if one has been created, then current state on enter state. And we're gonna go with get owner. B can tick state will be equal to true now. So now, oops. So now we're able to actually tick the state itself. And then at the end, we put an else statement, which basically is a response to the if new state is valid low level. And we're going to say, okay, state switch failed, it's an invalid. The new state you provided is an invalid state. So here's the check, and here's the else statement with the error message. And basically this is it for state switch by key. Now let's move on. We have init state manager as well, which will basically execute an initial switch state on begin play. And we need something in tick as well. So we need something in begin play as well. So we need to initialize the states here. Initialize states. And then in the tick, we actually need to tick our components. So in the tick state, we need to tick our states. So if B can tick state, if we can tick the state, then current state, tick state. Really simple. But if we have a debug, and this is, just my preference, I like having a debug just so I can see what's going on. We're going to show to the user, okay, your current state that you are in and the state history before this. So let me copy paste this because it's a bit of, there we go. So if there is a current state, we're going to add a message on the screen saying, okay, you are in this state. And if the state history number is above 0, so if we have a state history, then we're going to loop through it and we're going to add a message for every single state that we've been in previously. Really, really simple. Okay, and that is about it for the state manager. Now all we need to do is actually create some states for our character. But before we do this, let's actually give our character the component. So we're going to go to the state machine workshop character H. This is your H file for the character. And we're going to go to public and we're going to provide him with a U property, edit anywhere, blueprint, read, write, and category will be, I don't know, state machine or something. Who cares? Actually, let's leave it without a category. And we're gonna go with use state manager component, state manager. So in order to do this, we need to add the include. We're gonna go to source, custom state machine, public, state machine component. Just like that. And now we need to actually create the thing. So we go to our CPP file for the character in the constructor, and we're going to create it right before everything else. State manager, I'm gonna go state manager equals to create default subobject of type use state manager component with the text state manager. Right, and then after we've created the state manager, there's one more thing we need to do. We need to call init state manager in begin play. If I can find begin play, let's actually search for begin play. Oh, I don't think we actually have begin play over here. Okay, we can actually override it, that's fine. So we go to protected, gonna go virtual void begin play. And then we're gonna add generate implementation for it. We're gonna call super. We're going to call super on it, begin play, and then we're gonna go state manager init state manager. Just like that. Now everything is basically done. We just need to create our states and how they're going to handle things. Before moving on, I'd like to mention that if you want to use the plugin and so on, you need to edit the build.cs file where you want to include the files from the plugin. So for example, here is statemachineworkshop.build.cs for me, and you have to add the name of the module from the plugin you want to use, so custom state machine, otherwise the project won't compile. But anyway, you can go to Unreal Engine now, and if we open third person character over here, you can notice we have the state manager, and here we can mention the initial state, we can add the available states, we can say if we want to debug, we can say what kind of a history length we want, we can put in 5 or something like that. But in order to do this properly, we need to implement some states. So let's actually go ahead and do that. So now we want to create a new C++ class, and we're going to call it uStateBase. It's going to inherit from uStateBase. And I'm going to put it in State Machine Workshop, right where my, oh, let's not use that for it. There we go. We're going to call this player base state. So we're going to have one state that all the other player states will inherit from as well. You're going to see why in a minute. So let's create the class. So the reason why we created a base state for the player instead of a specific state like idle or run is the fact that we have a lot of common functionality in there that we're going to need in all the other states. So for example, right now we need to be able to consume input coming from the player controller, and every single state will need to be able to do that. So not just, for example, the jump state or the idle state. So in the player state base, if we go back here, we can define some variables. You can even define functions. You can do anything you want. Basically, treat this as your as the character CPP file. So instead of having like 2,000 lines in your character file, you're going to split it up in these kinds of files. But first, let's start with the player ref, which is going to be it's going to be of type, well, what's our character type? A State Machine Workshop character. So it's going to be like this, player ref, and then we're also going to override our onEnter state. Let's add the include for this one. There we go, and let's generate, let's generate the implementation. And here we basically call super onEnter state of onRef, and then we save player ref for later. So if we don't have player ref, then we're going to do a player ref equals cast this, and then player ref. Pretty easy stuff. Now we can also override the on exit state. And if you remember, we defined in our player controller over here in the interface, we defined a get jump delegate function. And through this, using this function now, we'll be able to retrieve the delegate, bind it when we enter the state, and unbind it when we exit the state. So thus we only have a single state actively bound to any delegate from the interface. So we won't have, for example, if you have an idle state, run state, you won't have both states bound on the same delegate at the same time. So only the active state will be bound to these delegates. So you won't have, for example, a use case where the player will keep pressing space, and let's say 7 states will be notified continuously about space being pressed. You will only have the active one, so a single one. So it's pretty efficient from that point of view. So as I said, we're going to override the onExit state, and on enter, let's actually bind that delegate. So bind jump delegate. And the way we're going to do this, we're going to include in this state, you can actually do this, this is pretty fine. You can include the interface. So custom player controller interface.h. And now using Kismet, using the Kismet library, we can do something like gameplay statics get player controller this 0, and we're going to include the file over here, and we're going to cast this to custom player controller interface, just like this. And now you can even add another U property. Well, not a U property because interfaces can't be U properties, but you can add like U actually not U, it's going to be I. My bad. So it's going to be something like I custom player controller interface and I custom player controller interface player controller, just like this. I'm gonna do it like a null pointer, and then basically we're going to save, well, we're not binding anything here yet, but we're save the player controller. So we're going to do something like if player controller doesn't exist here, it's not yet set, then we set it like this. Player controller equals to this, which is pretty fine. And now we basically have access to that player controller and to that delegate. So on state enter, we're going to be able to call if player controller. So if we have a pointer to that interface, and we can go player controller, get jump delegate, add U object, and then do this, and then U player state, base state, and we're gonna call a function on it. So you actually need to declare a function over here for this, which is going to be, let's say, virtual void press jump. And we're going to define a implementation for this, and now we can call press jump for it. Right, so every single time the player will press space, this function will trigger. And now in the onExit state, we can do player controller, get jump delegate, remove all for this. So every single time we switch states, we're going to unbind everything from this state, and the next state will be able to bind the delegate, and so on and so forth. So this is going to remove jump delegate, and that's pretty much it. We can even leave press jump empty. This one won't do anything. So now that we have our base state defined, we can go on and create more states. So let's go back to Unreal. We can create a new state, but this one will base on player base state. So let's create our two main states. Let's go for idle player state. Boom. And then it's gonna open Visual Studio again, doesn't matter. And then let's create if Unreal will talk to me, there we go. Create a new state that's going to inherit from player base state as well. Call it in air. No, let's just call it air player state. It's much better. All right, there we go. Let's close Visual Studio for now. We don't need it, so let's just close it. There we go. Now, if we go back here, we have idle state and air state. And remember, these inherit from uPlayer base state. So anything happening here will also happen in them. So this is why we save our player references, our player controller, and whatever else you need, you can save here at the start, and then you'll have it in all the other states. So what we actually need to do now is basically override the press jump function. And in order to do that, we're going to go to idle. We're going to do a protected, go virtual void, press jump override. So now that we've overridden the press jump function, we can make it do some stuff. So instead of putting this inside so instead of doing, if I go back to the character, instead of doing something like this, jump here and all the other stuff that you want to handle in the character itself, I'm just doing it in the idle player state, which basically splits off the code. And I can actually look at, for example, if I want to look at what my player can do when he is in the jump state, then I can look here and, nowhere else. I don't have to scroll through thousands of lines of code. I just have to go to the idle player state CPP file, and I'll see everything that the player can do in the idle state. All right. So while I am in idle, I want to be able to press jump and jump. But we actually need to see, okay, we actually need to define a way for the player to move from state to state. So while he's in idle state, what kind of condition needs to happen for him to move to the air state? So in order to do that, we're going to have to override the tick state, and we're going to generate an implementation here. And we're basically checking, okay, player ref, and we're going to check is, actually, I don't think I can do this, but let's try, is moving on ground. So in order to do this, we're going to get the character movement and then check is in, not is in air, but we're going to get the character movement and then check is moving on ground, which is going to return to us a Boolean saying, okay, is the character moving on the ground or is it in the air? And if it's moving on the ground, then nothing will happen. Actually, we can do this and negate it. So now, if the character is not moving on the ground, then we're going to do a player ref state manager state switch, actually switch state by key, and we're going to call it the key air. And you're going to see in a minute where we actually set these names for the states. Right, and that is about it. But we need to define functionality for the air state as well. So we need to go to air state, call protected again on it, and then virtual void press jump override. Then we're going to generate the implementation for it. And now I don't want to jump anymore. I want to do a G-engine add on screen debug message for 3 seconds, for 4 seconds. F color, let's call it blue. Nah, let's go for purple. And then do I am in the air. There we go, something like that. But now we need a condition for the air state to go back to idle state as well. So we're going to do the same thing, as an idle state, and we're just going to override tick state, generate an implementation for it, and then we're going to check, okay, is player ref, we're going to get the character movement, get character movement, get it, actually no, is moving on ground. So are you moving on the ground? Yep. Okay, then we're going to do a player ref state manager state switch state by key. We're gonna go air, right? And that is basically it. So we have to build, and we have to close Unreal Engine for a second just in order to build. Let's build everything. Hopefully everything works fine. There we go. Build successful. All right. Before we move on, there's one more important thing you need to do. At least in my case, you need to go to state base and actually mention that this is blueprintable. For some reason, it wouldn't show up in my editor. So let's just build again. There we go. And now let's open Unreal. And now you should be able to create blueprint classes of... You should be able to create blueprint classes of idle state. You can see idle player state. I'm gonna call it BP idle player state. And BP air player state. There we go. So BP air player state. All right, and now if you open these, you can see you can put in some stuff here. You can make it repeat. You can say if the state can tick, and so on and so forth. Right now we're gonna set it to true. I'm gonna set this to true, and we're also going to put in the display name for idle to be idle, and for air to be air. And if you go back to, if we go back to the character here, you can now see if you go to the state manager, you can actually add the states. So we have BP air player state. Actually have to give it a name again, air. And this is actually the key by which you switch. So this one doesn't really actually matter. This is just for debugging purposes, but this actually matters. So make sure you name these the same way you're going to use them in C++. And then we're going to add idle. You can add idle here. Boom. And now we can write in the initial state as well, which is required. I'm gonna go with idle. And everything should work fine now. So let's try and hit play. Oh, it seems it crashed. Okay, maybe I forgot something. Idle player state CPP 15. There's a violation. Idle player state 15. Oh, I'm not calling the supers. Oh my god. Don't forget to call your supers, guys. But I don't think this is the actual reason. It's basically because he can't find the player ref, if I'm not mistaken. Is player ref not being set? Ah, there we go. This was the actual problem. So I need to do this as well. Exit state. So don't forget to call your supers. And I need to put owner ref here instead of that. So now this should work properly, but I need to close this. Build again. Let's open the project again. It should be fine this time around. Okay, and if we hit, let's see if everything is in place still. Some data might not have been saved. Okay, air, idle, idle. Okay, everything seems to be fine. So if I hit play, you can see that my character is in the idle state. You can see it in the top left, right there. And if I press space in idle, you remember I'm going to jump. This time I jump, and my state will switch back to idle. Actually, never mind. That doesn't happen. Okay, wait a minute. Okay, so it seems we're not doing the state switch correctly from air to idle. So let's go back to the air state. And let's see what's happening here. So am I moving on the ground? Yes. Okay, then I don't need to switch to air. I need to switch to idle. This was a typo from my part. So I apologize. I think we can actually hot reload this. So let's just compile. Since I'm only using the CPP. Okay. Now if we play, press space, goes to idle, and then we go back to goes to air, and then we go back to idle. Air, idle, air, idle. So if I press space while in the air state, I should be able to see the message. So if I go to air and then press space, I can see the message, I am in the air, and so on and so forth. And you can basically use it for any kind of actor you want. You just have to add the component to it and do that setup. So you need to create the states in C++, inherit from them in blueprints, and then add them to the state manager over here, and you'll be able to switch from them with ease. That's pretty much it. This is the exact way that my state manager works in Heavybeat, and I use this for two reasons. I use it for my player to switch between states, because I have a lot of code that handles collisions and modifies a lot of variables from the movement component. And if I put everything in one file, it's going to be like 2,000 lines. So I split it up into different states. And I also use this for my HUD. I use a HUD for my to hold all my widgets, and I use this in order to know, okay, in order to give my main menu some kind of notion of being in a state. So if the game starts, I'm in the start state. If I press a button and I go to another menu, then I'm in that kind of state, and so on and so forth. And I handle widgets through it, and so on and so forth. This is really malleable. You can use it for anything you want, and I'll provide the files in the description if you want to tinker with it and you want to modify it further or whatever. This is by no means the most efficient way to do this. You can modify a lot of things to do it a lot more efficiently, but this one works for me. So yeah, this was a pretty long video. Unfortunately, I'm not used to these kinds of videos, so I apologize if I mumble a lot, or if something I said doesn't make sense. But everything should work fine if you copied exactly if you followed exactly what I did on screen. But remember, if you don't want to watch through all that, just download my files from the description below, and you should be good to go. All right, guys, thanks for watching. I'll see you later.